All right, everybody, I want to just review vector components really quickly and go through the problems that we had today in class. So first, we're going to draw some coordinate axes, and we'll draw a vector. We'll give it a length w, and we'll put it at an angle theta. And the x component of this vector is w cosine theta, and the sine is, or the y component is w sine theta, just like that. So that's the x and y component of the vector. And the idea is that think of it as an invisible triangle with these legs. Wx is the length of one leg, wy is the length of the other leg. And we'll go ahead and actually apply this to these problems here. So here we go. So we have here a vector pointing in this direction, like this, 35 at 57 degrees. And so when we write down its x component, the x component is going to be 35 times the cosine of 57, and the y component is going to be 35 times the sine of 57. And when we go ahead and solve, we're going to actually end up getting, when I put in my calculator, I end up getting about 19.1, and this will be meters per second, and 29.4 meters per second on the units. All right. Now here, we have a vector that is directed in a different direction. It's 34 degrees south of west, so let me explain what that means. West means we're going all the way horizontally. This is west, right? So north, west, south, and east, like that, north, south, east, west. Now, 34 degrees south of west means if this is west, we're going to go 34 degrees down this way. So let's be really clear. The angle that this vector at is 180 plus 34. That's 214 degrees. Okay. So our x component is going to be 12 times the cosine of 214, and our y component is going to be 12 times the sine of 214. And when we work that out, with our calculator, we're going to end up getting negative 10 meters per second and negative 6.7 meters per second. Now here, next vector, we have 8 meters per second south. What that means is we have a vertical component pointing down this way. So since we only have a vertical component, it's clear that we could say that the y component is negative 8 meters per second and the x component is 0. If you really want an angle to work with, you could use 270 degrees. And then for this last vector, we're going to have here 20 meters per second at 275 degrees. That's 275 degrees, 20 meters per second. And so our vector, let's set up x and y components. So we have x is going to be 20 times the cosine of 275, and our y component is going to be 20 times the sine of 275. And when we work those two out, we're going to end up getting about 1.75 and negative 20. Let's actually round this properly, though. I'm going to put a little decimal there so we get 2 sig figs. That would be 1.8 meters per second and 20 meters per second as well. All right, so that is basics of vector components, and we actually use this approach when studying forces and when studying motion in 2 dimensions, which we're going to take a little bit of a closer look at in our next class.